The AXI specification describes a point-to-point protocol between two interfaces, a master and a slave. Here we're going to see the 5 main channels that each AXI interface uses for communication. First, there is a write address channel and a write data channel from the master to the slave. Masters use the write address channel to send a memory address to the slave. It sends the address of where it's going to write the data that's transferred using the write data channel. A write response channel from slave to master is used. Once the slave has completed the write operation, it responds with a message to the master via the write response channel. Then we have a read address channel from the master to the slave. The master uses this to specify the address that it will perform a read operation from. The slave, when the data is ready, will send the data to the master via the read data channel. If the address is not valid, or the data are corrupted, or the access doesn't have the right security permission, the slave will return an error message. Note that each channel is unidirectional, so a separate write response channel is needed to pass responses back to the master. However, there's no need for a read response channel since a read response is passed as part of the read data channel. Using separate address and data channels for read and write transfers helps to maximize the bandwidth of the interface since there's no timing relationship between the groups of read and write channels. This means that a read sequence can happen at the same time as a write sequence. Each of these 5 channels contains a number of signals, and all of these signals in each channel have the prefix listed here. So we have AW for all signals on the write address channel, AR for all signals on the read address channel, W for the write data, and R for the read data channels, and finally B for the write response channel. Here, B stands for buffered because the response from the slave happens after all the writes have completed.